Hello everyone, my name is Angie Yurt, Head of Software at Gapminder and teacher at DIS Stockholm. Today I would like to give you a little introduction of Observable, the platform for collaborative messing about with JavaScript code and creating all sorts of charts, diagrams, maps, you name it. So I can give you some examples here. For every cohort of students that I'm having, I make this grade standing chart with nicknames, and here is like the different all sorts of ways they collect points for their attendance and assignments and quizzes and so on, and then they get the grade. This is interactive. This updates if you click on different snapshots throughout the class. It has a forecast there in the middle, and then by the end it disappears, and then they get the grade, and the data it gets, it pulls it from Canvas. All right, and then I have the other one, a project that is made by my students. So here is the map of international happiness. You can change the time slider to see the data through multiple years, and you can switch between the data sets, and you can see this radar chart on the side that shows you different measures, different contributors to happiness in the world. Here is the credits for the students who made that project. So as you can see, I have workspaces, this many workspaces that I'm working with. So I am using this platform Observable quite a lot. I'm using it for data analysis, data transformations, prototyping, making charts, making graphs. So today I'll show you how to get going and start doing that. So we starting by signing up to the service. I'll use my work email, test account, whatever. You should write your name here. Name your workspace. This is why I'm showing it, because when you create your observable, when you first time register for it, you would either use my invite link if you are in my course, or you would sign up by yourself, and then you need to create a workspace. And what are workspaces? Well, Observable has these different tiers, or like different plans of pricing, and those go by workspaces. They don't go by individual users. So to be able to select the starter plan, you have to attach it to a workspace, and then that's where you put all your notebooks and documents. So you'll need a name for it. So you can type, like, I would say Angie's workspace, yeah. Let's say we have it for school. Then you bash OK. It goes on to create an account, and that's the clean page. That's where we're starting from. I will go ahead and switch to notebooks. I guess Observable wants to promote these data apps that they have recently introduced, but the notebooks is like the easiest starting point to get going. So after you get to the notebooks, you can press this button plus in the corner, which will allow you to make a new notebook. It's like a bunch of templates that you can explore, and you can start with a blank page, and yeah, basically start typing. Uh, the first thing you type after this hashtag sign, that becomes the name of the notebook, and then you can just do like A equals 1, and then B equals 2, and then C equals A plus B. That's how you like referencing the cells that you have already created, and then you see the result of that. That is C equals 3. So I'll get more into it, but what we'll do now is I will give you a template to work with, and we'll go through the stages step by step. So I have set up an entire workshop uh, for you to follow. So this link, which I've pasted here right now, it's available here, but you can also see that link. You can find it in the description for the video. So that's the link you should go to. After you get there, you already see the entire workshop and what I've planned to show you. Yeah, and so this is on my official account. Yeah, so to make it appear on your personal account, you would need to fork this thing. So forking means basically making a copy of this notebook into your own account. Yeah, so I press the fork button and I leave that as it is, and I copy that to Angie's workspace. That's the one I've just created. And then if you go to notebooks, you see it has my first notebook and it has the introduction to Observable. That's the one we've just created. Yeah, or forked. If you go in there, it says it is fork of introduction to Observable, and if you follow through, you can see the origin of that code. Here's the plan for the workshop. We'll talk about what is a notebook, what it's made of, and how it works. We'll talk about the cell types. There is the three main cell types that I will share with you. These are the Markdown cell, the HTML cell, the JavaScript cell. Then we will see a way to do data preparation and visualization without using any code. So we'll explore the built-in datasets, we explore the built-in data table cell, and we'll see a chart cell. These are like specialty cells that allow you to do data process without coding anything. Yeah, and then finally we do, in the third activity, we import our own dataset from Excel, and then we use a low-code tool called Observable Plot to make a chart, improve it, improve some styling, add an interactive element. So that's what I was showing you before, the interactivity. And I'll show you how to get the result out of here and how to embed it onto your own website if you wish to do so. Then finally, we'll consider some tips for like housekeeping and etiquette, and then you'll get an assignment from me. So the assignment you're getting is a rather easy assignment that you could complete by doing similar things as I will show you in this workshop. All right, so as you follow along, you'll find me. You will find these yellow boxes that say "Show Me" on them. So the "Show Me" boxes, they give you a piece of code, which if you copy and just paste it as you normally would, you will get the same result as they're supposed to be. So it is usually collapsed like that, and you're supposed to do all the things yourself, or you're supposed to see how I do them and do them the same way. And then if you are stuck or if you need some help, then you can press that show me button, and then you see how thing is supposed to be done. All right, so with that, let's begin with introduction and our activity, the first activity. So what is a notebook? A notebook is a reactive document made of cells. All right, so as you've probably noticed already, there is these elements here appearing as I'm hovering my mouse over different elements. And if I open them, I see some kind of like content that is deeper inside these bits of information. Yeah. So this is what we call cells, and the inspiration here really just comes from spreadsheets. I can do like 1, 2, 3, 69, and then I can make a formula, right? I can make a formula to do a sum of the cells that I have here. 1, 3, that one, yeah. So that would be 75. I can do multiplications, and there's like many functions that it supports, and those functions are available through these formula, that you put into the cells. And here is what you see, how the formula is made up, what it's made of. So the formula is mentioning other cells, and because it's mentioning or referencing these other cells, changing them would, update the result of the formula. So this is called reactivity, and this is called the style of that happening is called reactive programming. So you change things here and some other things update. And if I change things like there, see, nothing happens, because these cells that I've just changed, they are not mentioned in this formula. So by mentioning my cells that I did mention, I made these 4 cells into observables. So the name observable of the platform that we are learning is really coming from this technical name of something in your code that is observed, and then other things would react on the changes of what is observed. Yeah. And then the cell that reacts on the changes, that is called a computed cell. So in a similar way, put this away, I have a color here. A notebook is a reactive document made of cells. And if I change this color, all right, that color updates. So why does that happen? It is because that cell, which has a piece of text with a color behind it, it listens or it watches the other data set, the other cell. So this one, the favorite color with the color element here, that would be the cell that is observed. That would be the observable cell, and this would be the computed cell. So the reactive element here is computed from the color that I give it. And it also depends on this function text color, which comes right from here. So this is an import from a different observable notebook. Yeah. So how did I find that? I was looking for some simple example of reactivity, and I thought, okay, I'll just like change the color of a text in some way. Then I googled change color of a piece of text in Markdown. Yeah, and this is what popped up from Google. So I ended up here, text color annotations in Markdown. I've seen how it's done, and I've just like followed these instructions. So import this in your notebook and then use that. All right. So this is the reactivity, and this is what helps you to build these interactive documents. You can add reactivity to filter, zoom, change the views, change the data, the sorting, so whatever you can imagine, you can do that. Okay, let's move on to the types of cells that we get to use in this platform. So the first main cell type that I would like to show you is the Markdown. I already mentioned it. So those like titles and this piece of text. This is the Markdown cell. An example. This other piece of cell is also a Markdown. So if I open this up, I can see how Markdown is really written. And then there's like a piece of HTML here, but this is just like a field of white space. So if I remove that, it just disappears. Yeah, this is like the true markdown situation. So markdown is a way to um, format your text by just writing plain text on the keyboard. So you can see that this double hash turns into header level 2. Here is like a single hash would turn into the header level 1. Then the triple hash turns into header level 3. There I also have a 1 for my ordered list. I also have some stars that result in this unordered list. And then I can add emphasis, like doing like double stars before and after. Yeah, formatting, easy and intuitive. Like even some chat apps, they support Markdown. So formatting easy and intuitive, so that turns into italic. Yeah, so this is a way that a lot of documentation on the internet is written with this kind of simple formatting written in plain text, and it's kind of like works as you would expect it to work. For example, like adding stars turns into an unordered list. So in Observable, our markdown cells could also be interactive. So to make them interactive, we need to mention some kind of variables in there. So I have this example here. This notebook is how many pixels wide. There is a variable in Observable that is called width, and width just tells you what is the size of your screen, or what's the size of the window that this notebook is running at. If I just type width, nothing happens. Yeah, so because it's just like a plain text. But to turn it into a variable that is observed, we add these kind of symbols before and after, and then it turns into, you see the output above here, 1152 pixels wide. That's the, maybe that's more precise, 1152. Yeah, that's about it. You can see how I'm like, by taking screenshot, I'm measuring the pixels. And if I like observe this number, like watch this number. If I change my size of my screen, you can see 928 now, and now it changes even more. So that variable changes as we change the screen size, and it updates. And because this cell is a computed cell now, so it's watching what changes are happening in the width, it is also updating this number. So now if I move on to showing you something else, this view of me authoring my markdown cell, it disappears. To get it back, I need to press that again. And if you want it to stay, you press this pin button. Then no matter how you switch between the cells, it will stay open, okay? And then there is also, so this is the source of what I'm writing, and this is the output of what happens, what is the output of what I wrote. You can also, there is also a way to hide the output. So if you press this I in the bottom, it would hide the output of your cell. And if you collapse it, so unpin and collapse, then it will hide the input of the cell. Okay? Next one. The next type of cell I would like to show you is called HTML cell. So HTML is a language of the web in a way. It is a templating, or it's a markup language that web pages are made of. It looks like this. You've probably seen it if you've been messing around with some kind of websites, or I actually have an example. So in my example, if I go to my Canvas page and start editing, I would edit it like a normal text editor, okay? But there's this button that allows me to view this as an HTML kind of source, and then I get like a more fine grained way to interact with this and change the actual code, how that becomes a web page. Yeah, so this is like a small example of how ubiquitous that thing is. The web is made of. So let's first consider what pieces we have here. We have a div element, that means division, and you have to like open these elements. That's how you open them, and that's how you close them. So you close by adding a slash, forward slash right before when you mention the element again. So this opens here, and this closes there, and it has a style where it has a fixed height of 200 pixels. Yeah, so if I change that to 250, you see that it got a bit taller. I have a header of level 3, which says HTML cell, that's what you see here. And then I have the unordered list with list elements that you can see. This is a web page. It is cumbersome to write, I mentioned it here, since everything is made of tags and you need to close them. So that I'm just saying that you need to not forget closing this list items, for example. These are the elements on your page, or they're also called tags. Yeah, so tags, you need to close them. And then there is a suggestion to change box background to yellow. So how would we do that? So here I have another division which says, but look what it can do. That's the content of that. But it also has a class. It has a class fancy. It's not a fixed name, that's something I just made up. And then there is a styling tag which fetches that fancy, it grabs it from the page, and it sets it to the coordinates using these instructions. So that's how you know where it should appear. It sets the internal padding. So if I would change that to like 10 pixels, you see that it shrinks and then shrinks back again. It sets the border, says that it should be red, the rotation, and the suggestion is that we change the background to yellow. You just type that, and then you run the cell, and it's yellow. In order to run the cell, for it to update, like, see, nothing happens yet, but if I press here, this play button, uh, the the cell runs again. Alternatively, I can press Shift Enter, and that allows me to do whatever I'm doing without moving my hand to the mouse, and that saves a lot of time because you don't need to like reposition your hands or do whatever. So Shift Enter is a super useful command that you can use to get the cells update. Yeah, so this is the HTML. This is how you write it. Then you hide your input, and this is how it appears in the web page. And that's what web pages are made of. All right, and then finally, I would like to show you the third major cell type, and that's the one I'm using all the time. It's called the JavaScript cell. So JavaScript cell is that's where you put the code. Yeah, the code basically goes here. So JavaScript is a code for making web pages again. So this is the language of the web. Another one, we mentioned HTML is the language of the web. And then this bit here, the one that defines the styling, it's called cascading style sheets, or CSS for abbreviation. So it's really three languages. So HTML is one, CSS is the other, and then JavaScript is a third. So web is made of these three languages. And then people make it more complicated, but it's basically these three. Okay. So JavaScript allows you to write all sorts of logic that would perform calculations, or if, if branches, if this and that, else that, or loops. For example, here you see a while loop. So while this condition is true, and as you can see, it is always true, it performs what is inside the brackets. And because it is always true, this loop goes on forever. Then this instruction tells it to wait 1 second. This number is in milliseconds, so that means the waiting time is 1 second. And then yield just means this is my cell output at this point, but keep running the cell. So at this point, it yields a new output that you see here, and then the loop runs again, and then it updates again. Normally, you would have just one output, and you would have just return like that. And if we just do this, the time freezes here. If I run the cell again, me running the cell would update this time manually. But we want it to tick like a clock. This is why we write yield, and then the clock is ticking here. So the time now is, and then there is this kind of formatting going on, and then it takes the date of now, so it takes your computer's time and formats it according to this specification, and has it uh, in the clock here. Yeah, so that's the result. To learn more about this specification, you would go to this link that I gave here, or you would just Google something like D3 time formatting, and then you scroll down, and then there's like a reference of all sorts of different ways you can use date and time to represent them nicely on the screen. Yeah. So this assignment suggests to add a date, so not just time, but a date as well. And by referencing it from here, so we can look for like the year. The year looks like %y. So it would go like this. And now if you see, we have year 2025, %m and %d would represent our month and days, zero padded. And to make it ISO standard, we put this punctuation in between. So we put the symbols, the hyphens, and then this space, as you can see, it is written as a space here as well. Our hyphens get preserved. In fact, we can mess about with any kind of text. For example, we can keep the time here. Then we say of that date, and then it changes to being time of that date. Yeah. So this is the JavaScript cell, which allows you to write the logic and do some computations and do data transformations and whatever else. Yeah. So that's it. These are the three main types of cells in observable notebooks. And we have now covered the cells, we have covered the reactivity. So what shall we do now? Well, let's look at some datasets and let's look how we can quickly visualize them. So to do that, we go to the next activity. Our next activity would be the no-code data prep and visualization. Before we start that, we need to mention that there are built-in datasets in observable notebooks. So sometimes I would just show you something. For example, I'd like to show you a scatter plot. And I bash a scatter plot here, and I get a scatter plot immediately like that. So, and then you like, wait, what's it showing? Where does this data come from? It is because Observable provides you these little starter pieces of code. That's how you can quickly search as you create a new cell like that. To create a new cell, you press this little plus between the cells, and then if you start typing scatter plot, you would get a suggestion here, and if you press here, it would give you this template code with a template dataset inside it, and the template X and Y, which are pointing to the columns of that dataset. So that cars dataset is built in to Observable. In fact, if we create a new cell, we can just mention it here. And what's inside of it is an array of some cars from 1970s. And these are, you have the names, and different other measures of them cars from 1970s. Yeah, so this is one of these typical datasets that people use in machine learning and data science classes, and it is here. That's where it's coming from. Another dataset that is built in is called penguins. So you can type penguins here, and then it gives you an array of 344 objects. That's what they are. So if you're familiar with Python, arrays are the lists and objects are dictionaries. Yeah, so these are just different ways to call them in JavaScript. An object consists of these key value pairs. This is key, this is value, this is key, this is value, and so on and so on. So for penguins, our array contains 344 elements. Each element is one penguin. Each penguin has these key value pairs, species, island, where that penguin was observed, and where its beak was measured in length, depth, and flipper length, whatever body mass, and if it's like male or female. Yeah. So these are our built-in datasets, and if you want a full list of which datasets are built in, I reference it here, and these are the different datasets. Okay, now when we know where these data is coming from, we need to be able to look what the data contains and be able to sort and filter it and do all sorts of um, transformations with the data. So I suggest now we create a data table cell and make it show data from penguins. Like you saw, if we type penguins, we get them here. If we set them penguins to a special variable, for example, my penguins, they become available in our notebook for the further use of a table cell. And now this plus button became gold. So why not just penguins? It is because these penguins and all these other data sets there's like so many of them, and if you start making a data table and then you get like 10 or 15 different suggestions which you're not even using in the notebook, it can be like distracting. Yeah, okay. So that's why we just name it into our custom variable, my penguins, and then this turns into like gold. This means, unless this didn't turn into gold, yeah. So this means that there are suggestions now, and in these suggestions we can create a table. So if I press here, it just takes my penguins as an input to this data table, and this allows us to nicely see what's inside the dataset. Yeah, we have the species, the island, the different metrics of the beak, the body mass, and sex here. Over the table, we have these overviews of like how many of them species of them penguins are the chin straps. Yeah, if you hover, you see the full name appearing here, and you see how many are Adelis and Gentoos. You can see how many penguins were observed on different islands. You can see the distribution of their beak sizes and their body mass and so on. So these things are also interactive. So let us now select the smallest penguins who were recorded on Dream Island. So use interactive tools on the top of the table. Okay, so first we go to the Dream Island, yeah? It's right here. So if we press that, the whole view becomes filtered. We see that no Gentoo penguins were observed on Dream Island, but there were some Adelis and all the chin straps. There is like these, this was the distribution of their beaks. They have really deeper beak than all the other penguins in the dataset. And then those were also smaller penguins in the dataset. See, the blue, the highlighted part, is a bit on the smaller side. So now we can also, so if I did that, yeah, this is like how I can filter part of the numeric values, and I'm trying to hit them at 4,000 grams, but it's like impossible to do precise here. So because it's impossible to do precise, so what I can do really is going to this filter button down here, and if I press that, nothing happens. I guess that's because I need to save first the view that I have pre-filtered now. So let us now save, and now this appears here. Okay, cool. So now if I go to filter, it goes body mass. I just need the under 4,000 grams. So that's basically all the, I want all the penguins that are smaller than a cat, like a regular size cat. And then if I save that view, I think I have my Dream Island penguins with a small body mass, so no one of them is above 4 kilograms, and I get these 96 rows in this output table. All right, and then the output of that table is saved in cell 3364. That's like the name of the output that we get from it. But to make it like more nice and friendly, we can rename it to small penguins. I copy that, and that is it. So now this data set is filtered, and we can reuse it as small penguins anywhere else. For example, if I add uh, like a regular JavaScript cell, I can mention small penguins, and it will give me the penguins that I have pre-filtered. Here is a picture of a Adelie penguin from National Geographic. All right. So next thing we do is we look at the chart cell. So a chart cell is something that allows you to make charts quickly without doing any coding. So let's add a chart cell. Let's point it to our small penguins fraction or piece of our dataset about penguins, and then explore how the smallness of penguins is related to sex and species. Okay, so to do that, we create a chart. So chart, and select data source. Then we choose our small penguins. That's that. And then for X and Y, for X, I would suggest picking the body mass. And we've already seen the distribution because it's like trying to guess what are we doing with our dataset. So for Y, it pre-selected the count here. And our count on Y results in a histogram. So that's what we got here. It is really the same as what we've seen here, just with a different resolution. All right, now we can start messing around with it. So we can set color to some other column from the dataset. We can set it to, let's say, island. Well, we just have the dream island, so that's not informative. We can set it to species, and then we have Adelies and chin straps. We can set it to sex, for example. Then we have male, female, and null. So null means that the value is missing. So maybe that penguin was a non-binary or something. Yeah. And then with facets here, we can make multiple views of the graph and have some of the marks go in one side, some of the marks go in the other side. So if I chose facet X, I can make my species go there. And then if I want to choose my Y and I set it to sex, so same as color, then I would have my females and males arranged like that, and the single non-binary penguin that we have remaining is here. If you want to exclude that specimen, that penguin, if you want to exclude that one, you would need to return to this data table and add another filter and add something like sex is male or female, or like sex is not null. Yeah, then that would disappear. Also, you can customize here. So if you want to customize, for example, the color scheme, to change it to like a more conventional male and female, so you can do, I don't remember which I've chosen here, but like set 1 would result in you having females in red and male in blue, for example. Okay, so what we just did, we've used this specialty chart cell to generate a simple chart like this without using any code. So that is a great tool if you just want to get started and explore your dataset without committing to anything like final that you would like to produce. So you want to just play around with different, so you can switch it dots, you can switch Y to different comment length, or like different other measures from the dataset. So you can quickly explore different combinations and different situations of what you are trying to look at, and then you can improve this further. You can press the customize, you can write the chart title. Let me just remove that. Let me set that back to count. Set that one back to bars. And then in the title, I can say penguin smallness. So what conclusion can we do? We can say that female penguins are smaller, and then there is no significant distinction between the different species, like adelies and chinstraps. Yeah, so penguin smallness, and then in the caption, you can have like here. Oh, that just goes under the chart. Okay, so that's the chart cell, and that's how you would use that. Third and final activity for today is importing the data. So we'll import a custom data set, and then we'll use Observable plot library to make a chart out of it. So for that to happen, let's go to this link called Anscombes Quartet. So this is a data set that is famous, yeah, for demonstrating why is it important to always visualize your data, because all of them, X and Y, have the same summary statistics like mean and variance, and then if you make a regression line, then it turns out to be exactly the same, but the four data sets are very different, and it's visible when you first visualize it, then you can see it clearly. Okay, so to work with this, let's select that. Let's copy the data. Let's paste it into a new sheet in Excel. So I have that here. Press that. Then I need to rearrange these blocks. I will move them like that. I will move like that. And then I will move like that. So what I'm doing right now is I am creating what we call tidy data out of the data that I have. A tidy data is a specific data format where you would have only one observation per each row, and I would rather add class there as a, one of the columns that I have. And then I can remove these, delete that, and delete that. So now the data set is in tidy data format. And here the first row should be the header of the of the columns, and the ordering and formatting after that doesn't matter. So, and we would drag and drop it into this observable notebook. So to do that, I just drag and drop my file, I find it here, and I release it. So apart all of my screenshots that I already have in my observable notebook, I now have this Excel file that I have just imported, and then if I'm here, my cursor is here, I press this button, and then it inserts itself into the notebook. So it did makes four cells appear. When it references the file, then it tells you which of them sheets are available in the workbook, and you can see that it's only sheet 1 that is available, so that is correct. And then inside that sheet, we can run workbook.sheet 0. That's like the sheet number 0 of all the sheets that we have. And then if we don't have headers in our data set, we would have that to false, but you can see that our headers need to happen. So let's change that to true. And then we have our headers correctly. We have X, Y, and class, and we have A, B, C, and D classes, and we have our distributions of X and Y coordinates for the points. Okay, so that's the data that we are interested in. So now let's use the chart cell to first generate an overview of whatever we are looking at. So if I press my plus button right under the data table here, it would then give suggestions. So then I can create a chart, and this is the same as if I would type a chart, a quick plot without code here, or create a chart. This is essentially the same thing, but when you see this light bulb, then it's a suggestion. Okay, and then it adds my chart cell here, which points to data. Data 1 is just a copy of data because we didn't apply any filtering to it. So that will be just a copy. For X, I choose X, and for Y, I would choose Y. And now see how my bars, which is automatically a selected mark here, will change to dots, which is now also automatically selected, but we can explicitly set it to dot. All right, and now facet X we would set to our classes, and we already have our 4 different charts. So at this point, we can be we can keep tweaking them with customizing and so on. Like we can enable grids, for example. But it's really like a very limited amount of options that we can have here. So the thing I wanted to show you is how to use this tool that offers you a low-code way to make the charts, and that's called Observable Plot. So in Observable Plot, you would write something like, I want my X to be the body mass of penguins, and I want my data set to be the penguins, and I want my Y to be just the aggregation, and then I want my color to be that and that and that and so on. So you kind of declaratively tell what you want each part to be. And to do that, a great way to get started is first make this a chart cell like I did now, and then press this suggestion button to create a new cell here, and then it says convert to JavaScript. So once I press that, it will create exactly the same view, but now with this piece of code that produced this thing here. And yeah, really cool. So it already has the grid, it has the data panels, it even like put a frame around them. Stroke opacity here is 0.1, but if I put it like 1, then I have more proper frames in here. I see some of the dots end up on the margins there, so I can change my X and Y. These are called visual encodings or visual channels, so I can change the domain of them to be, so what is X, what is Y? Maybe X should go from 3 to 20. How about that? See, now now X is not on the margin anymore. So maybe to 21 or 2 to 21. Is that it? I would also like to make it wider. Well, hold on, let's do that for Y as well, without being distracted just yet. And then it would go from where? From 2 maybe to 14. So in scatter plots, you don't have to start them from 0, so then it's okay, yeah? Yeah, I wanted to make it wider, so then I just set the width to either like a specific number that I want. For example, I want it like 300 wide, and it's too small. No, I want a wider chart. 500. No, that's maybe 800. Is that it? Yeah, maybe that's good. Yeah. Alternatively, you can set it to width of the page, which is again just a variable width, and then it will take the entire page. And this is confusing because this width is a property that you send into this function. Yeah, it's the one of the keys of your, you have width, x, y, marks, and so on. So this is just one of the parameters that you send into the chart, and this is the variable that's coming from your notebook. So when these two are equal, there is a shortcut. You could just write it like that, and then it still works. But this can be like weird to understand because it's not explicit. So an explicit way to write it would be like that. Yeah. Okay, cool. So then my suggestion next would be to rearrange these boxes so that they look like in this Wikipedia article, and they are arranged in a matrix 2 by 2 instead of what we have here, 1 by 4. So to be able to do that, we need to make some changes. So first, this view that we have now is only using facet by x. We will also use facet by y. We did that. And oh no, it just repeats the same logic for facet y. We need to change that. So to change that, we need to replace that from just pointing at class to performing some logic. To perform the logic, we need to now add functions. So functions is this way in JavaScript to basically run a piece of code from somewhere else, and you can pass functions as variables. So that's what we're going to do here. We want to pass a function nice fx, and we send our class into that function. So this d here that I've provided is referring to every element that appears in our visualization. So then this function would be called for every dot that we have, and then it would run this function nicefx, and it would send class into the nicefx. So to now make nicefx happen, we need to first turn this thing into multiple cells maybe. So with multiple cells, you see it's broken now. Nicefx is not defined. I make another cell and I set nicefx would be another function which we represent by just adding brackets and then this little arrow here. So here we have key, let's just call it key. It's not a fixed word, it's just something I made up. So key, if key equals A, B, C. So if it's A or C, then we return 1, and otherwise we return 2, and that is it. So now our A and C end up on column 1, and then B and D end up on column 2, because that's the 2 here. I won't go into details of how this thing works, so let's save that for a discussion about JavaScript and the control flow and so on, and logic statements. So then we need the exact same thing for nice fy, where we say if it's A or B, then we return 1, and otherwise we return 2. So then we copy that as well. So Fy would be here. And look, now we have our boxes complete. So then we can also adjust the height to make it more square. Yeah. So what if I do 400? No, I want to do 800 maybe. Yeah. So this is like roughly what we're aiming at. So what next? We want to color in the dots. So now all of them are have like holes inside them, and that is because we only so we don't define any fill on them. So yeah, let's just type fill will be orange because these dots in the original chart they were orange, and they're like too tiny now. So let's set radius to like 5. Okay, that's good. So now we have some dots which we have changed color for, and then let's change the style. So now we are really tuning the appearance of the chart. Our style would have font size. Let's try 16. See if it gets bigger. Yeah, that's good. And then we can also change the margin. So margin bottom, maybe 50 pixels. Yeah, that's all right. Margin top. So I want to give that Y, arrow Y, this one, a little bit more room there. Maybe 30 pixels. Did that change anything? 35. Yeah, that changed a little. There. Good. And then 1, 2, 1, 2, these are confusing for the facets, so I would like to remove the facet labels. For that, I do fx. I think it's called axis is I need to set. No, I don't remember what I'm doing. Yeah, and the other one is null as well. Okay, so we are approaching. Now we want to do the linear regression. So for a linear regression, there is a separate type of mark that we would like to use. And let's just try to add another cell and search for regression, so linear regression. And then if we bash enter here, it would again, like it does, you know, Observable always does that. It suggests us to use this linear regression Y on dataset penguins. See, so it's already pre-filled that to give us an example of how it should work, how it should look like. And as you can see, it's like very similar to, so if we add plot dot dot here instead of regression, we would get our penguin marks all over the place, yeah? So this is just like, we need the same configuration for both penguins and linear regression, except they just named differently. So if I copy my dot mark for the chart that I have, and I change that linear regression, I change that dot to linear regression Y, look what happens. We have that complete as well. So at this point, what we want to do, maybe we want to reduce this yellow color, the confidence interval, because the original thing didn't have that. So, and we can also change that fill is orange. Yeah, that's okay, maybe. But the stroke we can set to blue. That's to replicate the original chart. You see it's blue now. All right, so reducing the confidence interval. So to be able to do that, what I did is I just Googled a solution for that. You can also ask ChatGPT or anything like that, but you do it like this. Um, observable linear regression, and you need like observable HQ. That's how you tell it to really look for the platform observable and not just like some generic observable thing on the internet. Yeah, so here is the linear regression mark. You can press that, and there is the documentation that you would use to create those things. And you can see that this one doesn't have the confidence interval. So how was that made? The answer is, I don't know. It just looks like it should have come up. Oh no, it does have. See, that red area here is the confidence interval. Okay, let's keep looking. There are like different lines. Okay, it's explaining the Simpson paradox. Once you divide your dataset into classes, your regression or your correlation direction may reverse. Options. Here, confidence interval. So it is from 0 inclusive to 1 exclusive. So 0 is to hide the bands, and it defaults to 0.95. So this is what we need. The CI is the option we're looking for, and I've just I knew it's there, but I just showing you how I come to knowing that it's there. So in our options, and we can like make it formatted nicer. I bet there is like a button or like a keyboard shortcut that does this like nicer formatting for us. Don't remember, but like look them up, keyboard shortcuts. They can do nice formatting for you. All right, let's add another parameter here, which would be our confidence interval. Let's set it to 0. We have now removed the areas for the confidence intervals, and then you see that one. You see that one? Oh, look, it also has some kind of stroke that is like darker orange than what we already have. Maybe it's nicer to add those as well. So stroke, and here we can like add some kind of color code. So Mac has this color picker, which you should use if you have a Mac. If you have Windows, there is also a color picker utility on Windows, and then once we find what we're looking at, we have the code of the color that we're looking at, and then we can go back and we can just paste that color code. Did I mess it up? Yes, I did mess it up. I forgot the comma. Yeah, so these are the different strokes now that we have. But anyway, I wanted to now show you in a way to add an interactive element to our chart. So for an interactive element, we can do this thing now. We can add a new cell. It's going to be a JavaScript cell, but instead of like typing all the things ourselves, we will just look for a slider. So slider is suggested here. So among the inputs, and it is a range slider, which it pops here. And then if we run the cell, again, press the arrow here, the play button, or press Shift Enter, and then we have a slider, which doesn't change anything. But if we make another cell and we look for range, that's now the variable that comes from here, we can see that that changes. So by changing our range, and here we can call it confidence, whatever. This now becomes broken, yeah, because we don't have no range no more. But if we change that to confidence, that works now. For label, we can call it we can have our label set to confidence interval, and for our boundaries here we go from 0 to maybe 0.99, so we should go to 1, but we should not include 1. So that is like where we would then stop, and then our step could be 0.01. And if we run that cell again, we have that thing working. Cool. And then this variable confidence, this we don't need. Yeah, and this we can collapse so that we just have the slider. So this confidence we can plug in here, and we can replace our confidence interval to that variable. And now we got the bars, the ranges back, and you can see now I can change those interactively. So this is the idea behind interactivity, and how now this cell observes that thing and it reacts to the slider. And there is also like a cool trick that you can use after you've made a bunch of cells on your notebook and it starts being large. You can press this button. So this is open minimap pane, and the minimap shows you like dependencies between data cells or between the cells. So confidence here doesn't depend on anything, which is correct, but there is one data set. There is one cell that depends on the confidence. So if I press that one, I jump to my other cell, this one, and I can see that it not just depends on confidence, but it also depends on data 1, which comes from here, or here from this data table. It also depends on nice fx and nice fy. So these are the functions that we made for computing x and y facets. Right? The order of the cell doesn't matter. So you can arrange these cells how you please. So for example, if I move these nice fx, nice fy, I move them above the chart still works because it has its own logic of like when to change and when to react to the changes, which doesn't involve having to look at the order of the cells in the notebook. All right, that we don't need as well. So this is pretty much it. This is what I wanted to show you, how to make a chart, which we now made with code, but we also didn't have to code anything in detail. So we didn't have to like program how we position the circles. We didn't have to program the labels on the axes. We didn't have to program how the confidence intervals are computed. So all of that is done for us with this thing called observable plot. So if you like plot, I do like it very much. You can go to the plot, so observable HQ/plot, and here you can see the like introductory page, and then if you hit examples, you go to this, well, again, that's a notebook. You can go to this notebook of examples and get inspiration of what kind of things you can do with observable plot. And amazingly, you can do quite a lot. You can have this, I don't even know some of them. What is burn down chart? Let's click that. So there's now the example of how to make the chart with this. And a great skill that you could have is you can see the issues is the data set that this chart consumes. And then if you have your own data set that is similar to the one that they have here, you can swap that to your data set in your own notebook. So you fork this thing, press fork, you get a copy of that. You swap this issues data set with yours, and then you have a chart which you took from here as an inspiration. Yeah, so a big skill, or like a big part of it, is being able to reuse someone else's code. Yeah, or this radar chart, for example. Yeah, so the dataset for a radar chart should be rather simple. It should be something like an array of objects with some parameters in them. Yeah, so whatever. Yeah, so you know what to do then, to go to these examples and then find the one you like and make it work for your chart. All right, so this was like where we were going towards. We can also add like a title quartet. Don't forget the comma there, and then we have a title here. So now we have a functional chart with what we want there to be. Yep. So finally, I wanted to tell you how to embed this chart after it's done to an external website. So in order to be able to do that, first of all, your notebook needs to be published because otherwise you won't have access to from to your notebook from an external website. So then you press this publish button or share, and then public here should have a view access. So public can view, that is it. You press save, and now your notebook is public. And now what you can do is go to the cell that you would like to publish. You press that kebab menu on here, and then you will press embed, but you see it's not possible yet, and then it says name this cell to embed. This is like really good that they mentioned that, because otherwise, like, why would they not be able to embed it? So to name this cell, you can type something like cell to export and set it to equal whatever you have. And then our cell to export is now named. You can verify the name here. This is also where you would see that name or be able to change that name for a markdown cell or a HTML cell, yeah? But for JavaScript, you just give it a name like that. And then press here again, then embed becomes available. You press that, you have a cell to export, you have a preview how that would look like. So there you have iframe, and this is the embed code. So you take that, copy, yeah, now we go elsewhere. I don't know if I don't know if I would be able to embed it here on Canvas. Remember, I was showing you that it has this this button to show me the code. Maybe it will work. Let's try it, see what happens here. So if I bash that here, so with 100% height, let's set it to pixels. It might work. Hey, it is here. So easy, but let's see, me saving that. And then look my chart in here. There is also this thing called CodePen, or like JS Fiddle, which is like a website playground, and you can paste any HTML here, run this, and then you can verify that whatever HTML you're posting is functional. Yeah. So this embed code with iframes, you might have seen that before. If you, for example, go to YouTube let me show you on YouTube. If you go to any video on YouTube and then you press share, there is the embed thing here, and then you can take that embed code, you can press copy, and then you can paste it in here. So this is like, this is how you embed things from other websites on the internet. Yeah, so I have a video here now, and I have the chart here as well, and these are both iframes. So this is like width. I can set it to 800 maybe pixels. Um, some of the browsers are sensitive to that. They want pixels really spelled out. Yeah, I don't know. Just did something. 600 pixels for that one. Yeah, and then you can like design and like tune the appearance of that. And then you have a website with pieces of embedded charts and videos on it. This is it. Finally, I would like to conclude with two things. First, I would like to give you some tips for housekeeping, and then I will give you an assignment. So the tips for housekeeping, I list them here. So cells can be rearranged. The execution order doesn't depend on the order of the cells, so do feel free to arrange them how you like. For example, the appendix below, these are my screenshots that I have been using throughout the document. They just here in the basement, and they don't have to like mess and like distract the reader from anything else. Then use hotkeys. Yeah, so there is this document with keyboard shortcuts and navigation between the cells. This section is like the most useful one, so learn this keyboard shortcuts, and you will be more nimble with moving around the cells and interacting with notebooks. The first cell should start with a markdown. Yeah, first cell should be a markdown with a title, the first level title in it, Introduction to Observable. Like if I rename that and then go to notebooks, Introduction to Observable text ends up here. So when, hold on, I'll show you how it looks for me. So if you are my students, then think of me when you're naming your notebooks, because uh, this is how I see them. I have like for each course, I have about 150 of them, and I end up with like having a bunch of like similarly named or even sometimes not named notebooks, and then I don't know which one is which. So give them like descriptive names, and now you know how to do that. But also, this one doesn't have any thumbnail on it. So to be able to give it a thumbnail, you find like a good picture of your notebook that you want to share. You would then take a screenshot of that picture, like I'm doing now. It's good enough. And then you go to this share button, and then for thumbnail, you select custom and you upload the file for the screenshot. That one. Yeah, that's the one. Okay, found it. And then you can like zoom it a little bit more or a little less. Let's just make sure axes are a little bit visible, and let me just show you that thumbnail is now here. So again, if you think of like how your notebook appears in the list with uh, many other notebooks, like I have a bunch of these empty ones, and I'm not able to use my pre-attentive features of my visual search in order to see that your notebook is the one I should be looking at. Okay, then in sharing, make sure that I am able to see the notebook that you made. So at least make the team access can view or edit, because then you could have my comments and like me improving your cells or showing you how to do things in separate cells. So I would need the edit access for that. But also it's like useful to just have them publicly viewable unless there is some secret data that you would like to keep secret in them. And finally, give them some nice descriptive URLs. So now it's like this code that is only good for robots, but not for humans. But if I switch to the custom, then there's introduction to observable text. We can remove that. And then we can make it even shorter. So instead of introduction, we can say intro. We can already copy that if you want to paste that in Canvas, and then you don't forget to hit save. So now this is intro to observable. Now we have a descriptive link that is pointing to whatever we've just made here. Yeah, a suggestion to keep tutorials in your own workspace. So in order to not populate the shared workspace that we all have and not have like 150 things here that all are introduction to data wrangling, or like I made this tutorial, I made that tutorial, they all have like the same names and they all have the same thumbnails, and then I'm not like able to see navigate between which one is which, and they're also not that interesting because they are all the same. So we can keep those in your private workspaces or personal workspaces. Don't forget to have the view permissions or edit permissions for me to be able to see them. But in the shared workspace, put your group projects, that's the red assignments, and the orange projects that are the individual assignments. Yeah, and finally, if the notebook becomes too large, split it into multiple parts and import them. So we've seen before how this notebook imports the text color from that other notebook. So you can do the same things, but with your own code, and you can import things between your own notebooks. We actually have two of them here. So you have my first notebook, which is that one. So if you click that and then make like a nice shared link here. So let's import C from it. Import notebook. So it has a template. So I want my C variable from this notebook, and it starts with an @ sign. So I only need this part, yeah, surrounded by quotation marks, and that's it, yeah. Oh, fail it to load. I wonder why would that be the case? Can anyone guess why that would be the case with my first notebook? Could it be that I forgot to enable permissions? Coming back here. And now it succeeded. So if I now call my C, whatever, no, I don't want cars. I want just C. It is 3, just as it was in the other notebook from where it was imported. Okay, and finally I have an assignment, which if you are in my class, that assignment is a separate individual assignment and it gives you a separate point. So if you are just doing the tutorial, then you're done. You close the video, you send the link to your thing that you have just done now, and that's it for this assignment. for the tutorial. If you pick to do the assignment that is called pizza orders, the individual assignment, it is introduced here, so you can, if you feel like, you can continue following these instructions and do the pizza orders. So you import the dataset like this. It is based and inspired on the course Data Visualization Fundamentals and Best Practices by Robert Kosara, who works on at Observable. So he made this amazing introductory course where he has an assignment in the end with this dataset, pizza orders. It is a synthetic dataset about a fictional pizza chain. They sell pizzas in California and Nevada, and you are supposed to import that dataset with pizza orders, explore it using a chart, so do some visual exploration, and then explain something that you found using charts. So at least do 3 charts when you work with the dataset. So explore some things, use the charts to explore, and do explain something. So use the charts to explain. For example, find an interesting pattern or factoid, explain it using charts and text. Here is an example of unsuccessful attempts at solving this assignment. So you have tried to do something, but your chart is completely useless, it's not readable, and these numbers are cut off here, truncated, and the color scale is not possible to visually decode and match the different things to their names. And then the California and Nevada, they look exactly the same. And in fact, California sold many more pizzas than Nevada. So this chart is also wrong because it doesn't show the data correctly. You get a whole point if you've used summary statistics, but you've used them incorrectly. So for example, here you've used the count for computing your bars instead of a sum of the orders. Let's see, do I have the data here? Yeah, I do. You've counted lines that have orders available. So you counted rows in the data instead of taking the sum of the actual orders that you have been having. So that means that for every day we record a number of pizza orders in California and Nevada, and of course both California and Nevada have seen the same number of days. And that's why you see the same height in both of the bars. But if you actually validate that and maybe do some like calculations manually on the dataset just to verify, you will see that California sold many more pizzas than Nevada. And you will be able to catch that mistake and correct it. In order to correct it, you need to use a different summary, which is the sum. And then if you do the sum, then you end up with this kind of view, which is better. Yeah. Finally, you get even more points if you go away then from these summary kind of views and show the actual data points without aggregating them. So for example, here I'm showing different veggie pizzas for different sizes. This is one size, this is the other size. So here is veggie is only ordered in large size with some gaps in the time, but medium is ordered over the Christmas a little bit. Yeah, so that would require you to do a specific data transformation. So you can look at the data and find out which data transformation you need to do to be able to make these kind of charts. And these kind of charts are better because the summary charts, they would hide interesting patterns into just like a couple of numbers, yeah, per pizza category that you have. while this would show you the nature of data with the outliers. That's like the most interesting things to look for. Yeah, any questions, please put them in comments or ask me directly if we are in contact. Uh, yes, have a good day.